Today, we are airing the Avalanche Quarterly Webinar I did earlier this week for Token Relations with 3 very smart Ava Labs engineers. It's important because Avalanche9000 went live last month, which was the network's largest upgrade to date. We talk all about that, what it means for developers, for users, and more. So I hope you all enjoy. Hello, everyone, and welcome to the Avalanche Quarterly Webinar with Token Relations. I'm Jacquelyn Melinek, the co-founder of Token Relations. I'm excited to host this conversation with Ava Labs engineers, Stephen Buttolph, Aaron Buckwald, and Michael Kaplan. We're going to be discussing Avalanche9000, which went live last month in December, and it was the network's largest upgrade. I'm sure Avalanche ecosystem members saw a lot of announcements about it, but they really didn't get to talk firsthand with these engineers. So I'm excited to talk to them about it, the technical upgrades, and a lot more happening in the space. In this discussion, we will also allow for Q&A from the community. So if you have questions, feel free to post them, comment them wherever you're watching this from, and we will get to them. I'll also remind you guys throughout the webinar. With that said, let's get started with some background and context. Avalanche, which is the primary blockchain of the network, currently has about 132 blockchains built within the network. And every chain built on Avalanche is an L1, and it has 43 active L1s at the time of recording. This past quarter, as I mentioned, Avalanche's biggest network upgrade, Avalanche9000, went live. Wait, it's 900,000. 9,000. Avalanche9000 went live, and it aims to make the ecosystem more interconnected, as well as making the network cheaper to deploy on and even cheaper as a user, which I'm sure we'll discuss more in a little bit. Now that we're in the first quarter of 2025 and the network upgrade has been alive for a little over 3 weeks now, I'm excited to talk to these guys about everything. So to start off at a high level, I wanted to ask you all, before it even launched, what challenges did the upgrade aim to solve?
So maybe I can get started, I guess. I think for me, this upgrade really focused on reducing costs across the board. So as we mentioned, both user costs for, say, users on the C chain, which is the smart contract EVM compatible chain on the primary network. We wanted to reduce the costs and make that as cheap to use as possible. But then also for people launching subnet and now layer ones on the P chain and interacting with the P chain, we wanted to make that as cheap and as flexible as possible. And then the last component is the actual kind of running of layer ones. We wanted to make the infrastructure costs as cheap as possible for that. So really, I would say kind of across the board for me, we've been focusing on reducing the costs and reducing the barriers to entry kind of across the user space of users on the C chain to layer one kind of creation to validator actual like infrastructure hosting, really across the whole stack, just reducing barriers to entry and reducing kind of costs. So that's kind of the main high level motivation that I see. And there's a lot of kind of smaller sub components that fit in as well, but that's kind of the high level vision that I felt was coming through with this upgrade.
Yeah, the one piece I would add on to that, I think, in addition to reducing costs across the board, is one that Stephen touched upon briefly, which is the increased flexibility in how L1s can be launched and in their staking dynamics. So previously, all L1s needed to manage their validator set on the P chain and using the rules defined by the P chain, which was very limiting to either permissioned kind of multi-sig proof of authority chains or a predefined staking curve that was had limited parameters. And now we have a much more extendable framework where L1s can define their own mechanism for managing their own validator set. So whether that's proof of stake, proof of authority, or any unique combination of them and hopefully of many other experimental features in the future. We kind of have that testbed and a large increase in the flexibility that L1s have to define those themselves now.
Mm-hmm. Yeah, I think we originally called this L1 driven validator sets, or actually subnet driven validator sets.
That's a long title.
Yeah, exactly. So, but L1 driven validator sets, because if you look back at sort of what it was before the Etna upgrade, it was all transactions that you used in order to manage the validator set of your own L1 was all user facing transactions in the P chain. which made it much more difficult to actually manage. It was restrictive, as Michael had said, to the transactions that we had actually gone and implemented. And so much of the value that comes out of crypto is just the composability that you get when you open it up to users to actually program and build whatever they want. So there's two things that we got out of this. One was that you can actually move the contract responsible for managing the validator set from not even being a contract on the P chain, just those user-facing transactions, to a contract that you can actually put on the C chain, on your own L1, wherever you want, really, as well as giving it the composability and programmability. And because people generally want to have good defaults with customizability, we have different implementations of that provide all of the things that you would typically want, as well as it's just a contract. You can override it, you can extend it very, very easily.
Mm-hmm. Yeah, in terms of customizability, what are kind of the key aspects there that are now available that weren't prior to the network upgrade?
So before Steven, do you want to talk about what was there on the P chain before the network upgrade?
Yeah, so I would say when the network first launched, I would say the focus was definitely on getting the primary network launched, and with the expectation that the subnet and now layer one infrastructure would continue to evolve. So when the network first launched, what was really supported was primarily permissioned subnets. So essentially what that meant was there was some owner of a subnet, some set of public keys registered on P-chain, and they could basically dictate, hey, this person can join this network, this person is removed from this network, so on and so forth. That was very much not like our end goal vision. It was just kind of, okay, let's get like this kind of idea out and be able to kind of iterate on it as we move forward. We extended that, I think, in the BAMF upgrade, which was a couple upgrades ago now, where you could add not just based off of some key explicitly adding people, but you could add based off of staking of what we call like these Avalanche native tokens, which were tokens that were like minted within the primary network and able to be transferred to the P chain. And that system, while technically adding support for permissionless networks, was really restrictive. It enforced a similar minting curve to that the primary network uses, and it really just didn't give the flexibility that people wanted with defining their own staking rewards, defining who can actually join as validators, like what the membership condition constraints are, various things like that. And so this kind of redesigned that whole mechanism with saying, we don't want to like specify any bounds. We just want to say, here's a mechanism where you can essentially send a message, and that message will get interpreted on the P chain as add this person as validator, remove this person as a validator. And the kind of origin of that message can be any code that you choose to write within your own layer one or embedded on the C chain. And so by moving from a kind of fixed scope of here are the options that we have to, hey, now you can write any code that you want and define your own constraints, it really just completely changes the game as to like how expressive these kind of constraints are.
Yeah. I see that as like an opportunity to open up the doors in so many different ways. And then even on the front of Avalanche9000 making things extremely cheaper, to your point, Steven, when we first started this conversation, it's like 99.9% cheaper. It's not even like 20%, 50%. That's a lot cheaper. And that also provides a lot of accessibility to developers who maybe like that was the roadblock before, like they couldn't afford it or they didn't want to pay it, whatever their reason was. Suddenly that reason doesn't necessarily exist. So since the network upgrade, have you guys seen more developer interest? I'd imagine yes. And if so, what is that kind of looking like?
Yeah, I would say absolutely. And really starting from before the upgrade even went live, I think there were a number of teams already looking ahead and eager to build on what was to come, which was awesome to see. There are teams like Suzaku building unique staking contracts for EVM chains on Avalanche, kind of going the restaking route. I think we've seen a lot of traction with these contracts to manage validator sets, whether that be like staking NFTs or adding unique requirements for who is allowed to become a validator. That's been very exciting to see. I think also because of the fact that the barrier to entry to launching an L1 is significantly reduced, now we're starting to see more and more traction and experimentation and adoption of interchain messaging between these L1s because they're coming about more rapidly, and it's easier to play around with them as a test bed to test things out.
I actually had questions on the interchain messaging, so we will get to that. But on the front of like the deployment fee, it was 2,000 AVAX, right?
Yeah, it was 2,000 AVAX, not for deployment actually, but in order to become a validator for an Avalanche L1 prior to the upgrade,
right,
you had to also be a validator of the primary network. And so the primary network had a requirement that to be a validator there, you needed to stake 2,000 AVAX. So it was sort of transiently pushed onto any subnet that every one of their validators had to stake 2,000 AVAX as well.
Right. And now that that is essentially removed more or less, like how does that impact the network's sustainability going forward, especially when it comes to validating and staking on the network?
Yeah, so that's an interesting question. So I actually think that with that constraint, we were kind of bounding like the amount of work that the Avalanche network could do, right? Because by saying, hey, in order to participate in the subnet, you have to be a validator of the primary network, you're limiting like your available compute to just those primary network validators, right? And like there's a lot of primary network validators in Avalanche compared to, many blockchain networks, but 1,500 validators is not necessarily like the end all be all of scalable compute for, the Internet of Finance, right? And so really like that is almost in and of itself a non-starter with respect to that kind of constraint. And so removing that really allows like this L1 subnet infrastructure to kind of flourish and grow by removing that very large constraint. One additional component that is very interesting is there are a number of kind of institutional partners and people that for regulatory reasons could just not, it was a non-starter for them to actually be a primary network validator. And so by removing that constraint as well, you're opening up to a whole new kind of group of either actual or perceived regulatory concerns could not be primary network validators. And so it opens, kind of your space up both theoretically and extremely practically. Yeah.
Yeah, no, that makes a lot of sense. Sorry, go ahead.
I was just say one interesting aspect of it that I think is not talked about as much is that 2,000 AVAX to become a primary network validator was an upfront cost, but it wasn't a fee in the sense that you're not spending that. You are staking it and you are earning rewards on it in the form of newly minted AVAX when your validation period ends. So you'd actually end up with more than 2,000 AVAX at the end of your validation period. But now, one, you don't have to stake the 2,000 AVAX up front, but you pay this much, much smaller continuous fee. Those fees actually get burned. So it's an entirely different mechanism. And I think the fact that those fees get burned is rather than being locked for a period of time, but then resulting in more rewards being issued is another nice feature.
Yeah.
The reality of the 2,000 AVAX minimum fee is that for the primary network, it sort of made sense that, we're going to have something there. But for everybody else, it's sort of this artificial economic constraint that makes it harder to launch L1s. And we want more and more people to launch L1s because that's really how we scale the value of launching an L1 on Avalanche in the first place, right? It's all about interchain messaging, which I know you said we'll get to later. So I'll hold off on going into that. But it's all about the network effects. So this is the whole point of the P chain, is that it is a sort of hub and spoke model whereby connecting to the P chain, you're able to connect to all of the other value and all of the other chains in the ecosystem. And that's only actually valuable if there is other value services and value to connect to in the network. So by putting that artificial economic constraint there, we were really sort of like shooting ourselves in the foot or limiting what could actually be built on Avalanche. And I think that was just the wrong model to go about building more valuable services on Avalanche in the first place. And I think, a good example that I like to give is if you look at Facebook in like the really, really early days, I mean, I'm a huge fan of the social network, so I'll try my best to quote it. You have Mark Zuckerberg talking about, I don't want to put ads on this because it's not cool, right?
Mhm.
Avalanche isn't cool yet, right? There's not, we have 132 chains, maybe 30 or so that are active, but at the end of the day, it's not cool yet. It's not really where we want it to go yet. And that comes down to, we want to launch more and more chains that are going to connect to each other and have this use case for that interchain messaging.
Mhm.
And so I think the strategy is, and the strategy and also the ideology is, we shouldn't have those artificial economic constraints there, as well as it's too soon for anything like that. Not that I think it should be there in the first place. I don't think it should. But it's also the wrong strategy when it comes to growing the overall Avalanche network. So when people have those criticisms about the fee structure or the question of, are you worried about this? Not in the slightest, to be quite honest.
Yeah. No, that makes sense. Aaron, I think Avalanche is cool.
Oh,
you got to give it some credit. Come on.
All right.
It's cool. You don't need ads to, I can say it. I'm the host. Yeah.
It's cool.
Exactly. Yeah.
Are we going to add ads to Avalanche Go?
Yeah, this is going to have a big ad across it.
No.
Right. There we go. I mean, obviously, you guys talked about fees in your responses, and part of the network upgrade was the implementation of a dynamic gas fee during off-peak hours, with considerations involved in transitioning the C chain, the P chain, the X chain to a dynamic fee mechanism. Have you gotten any feedback on whether or not this has influenced any user behavior? Because I feel like if it were me, I would be like, I'm just going to do this during off-chain hours or off-peak hours unless I really need to get it done now. How do you kind of like look at that? Or what are the conversations now being had now that it's implemented?
That's interesting you say that. Do you do DEX? If you want to do a DEX swap, do you wait for off-peak hours to do it?
Depends how cheap I'm feeling, right?
Okay. I haven't heard that before, so I was interested.
Yeah, I mean, but like, listen, if it's like 3 a.m. when I'm sleeping, I'm not going to do that. Like, if I see that, it's slightly cheaper, maybe. But like, also, what does cheap really mean? Like if it's like 50 cents, $50, like, how do you measure what's cheap to a person is different, right?
I have actually heard of large institutions doing that, where like, say you need to rebalance your books, they will actually wait for cheaper times of the day. So I don't know that a normal individual does that, but that is certainly something that.
Hey, I wait for Uber's price to go down, so I'm that type of person.
That's more expensive than Avalanche was either way, though.
Right. Okay,
I've never paid as much for an on-chain swap.
Well, okay. Has it affected transaction volume on Avalanche across the network, or no? Essentially,
I think there's a number of interesting aspects to this, and the long and short of it, I think, is yes. But I can take a step back and kind of set the scene beforehand. So this upgrade on the P chain introduced a dynamic fee mechanism, which previously was not there. And that definitely helps the robustness of the chain, because during those peak hours, if the congestion or load on the network increases, we will see the fee rate rise, such that the network is able to handle that load properly. And prior to the upgrade, it was a static fee mechanism. And since then, I think the effective fee rate or transaction fees have actually come down significantly on the P chain. Stephen might know best there. But the other aspect of it was the C chain, where there already was a dynamic fee mechanism, but it had a much higher bound on how low the dynamic fee could actually go. And we saw, I forget what year the dynamic fees were actually introduced on the C chain. I think it was 2021. But we've seen since 2021 that the adjustment of the fee rate based on network load is highly robust. I think about a year ago or so was the inscriptions craze, and we saw the fee rate respond accordingly to the increased DPS during those times, and the chain chug along just fine. So removing that guardrail of the lower bound of how low the fee rate could go was a big enabler during times where there aren't such a high load on the C chain. And we have seen a big uptick in the number of daily active addresses on the C chain. Not sure if it's directly correlated necessarily. I know there's a number of factors. Definitely not going to claim to be a expert in how to get people to use a blockchain network, but there's certainly at least some level of correlation there between the number of active addresses on the C chain and when the fee rates came down. So that's great to see. I think it will hopefully enable more users to get a entry point into Avalanche and go on from there after getting their feet wet on the C chain.
Mm-hmm.
Yeah, I think to comment on the P chain side, I was looking actually just before this call because I was interested on the kind of relative like transaction pricings. And I think so previously on the P chain, I think the smallest transaction fee was a thousandth of a Vox, so like 1 millivox.
Mm-hmm.
And I was looking through various transactions on the Explorer just now, and most of them are about 100th of that cost. So the P chain was never really throughput limited, but the reason that the fees exist is to prevent any kind of DOS attacks. So you expect that in the normal case, the fees are basically going to be essentially free, and that is where it is right now. So that's the really nice thing with introducing the dynamic fees on the P chain.
Mm-hmm.
I was also looking at the C chain, and I think that if you look at the kind of gas used per second over the past, say, like 3 months or so, there's certainly a growing uptick. But I would, the reasons why blockchain usage goes up or down is probably, who knows. It could definitely be because of reduced fees, but it also could be just because there was a cool DEX that launched or something. So
yeah,
it's hard to tell sometimes.
It's nominal, and it's pretty cheap all across the board, even during the peak hours, right? So maybe I don't need to wait till 3 a.m. to do a transaction. That would be insane,
especially on the P chain.
Exactly. Okay. The moment you guys have been waiting for, because you've been talking about ICM, I want to talk about interchain messaging on Avalanche. What do you think is the biggest driver behind maybe the evolution of it and the growth coming in this year? And then we could kind of dive into more conversations about like communications within the ecosystem and so on. Aaron, feel free to start because I know you talked about it a few times.
As many of you know, the Ethereum ecosystem is vast, but it's still extremely fragmented. Are you tired of how complicated it is to move assets across different chains? I know personally, I am. So with that said, I want you to meet Across, the most reliable, fastest, and cheapest bridge in the Ethereum ecosystem. Across has over 15 billion bridged and 1.7 million users. It's making cross-chain transactions simpler for everyone. Its intent-based design means users will get lightning-fast transfers between Ethereum and L2s like Base, Arbitrum, and Optimism in seconds, not minutes. For users, it's seamless bridging. For developers, it's providing native cross-chain integration. Across Protocol is erasing boundaries and unifying Ethereum. Experience the future of unified crypto infrastructure at across.to. That's across.to. Catch you all there.
Sure. Yeah, I think I heard from somebody once that he thought the best reason to use crypto was it allows the random college student to build something, deploy it, and compete with Wall Street in a day. I think that's really just cool. And I think he was saying that about smart contract, right? You can go and deploy a smart contract cheaply. You can go and deploy it on any chain that's out there. And it's a really pretty amazing ability to go out and deploy a DEX that can get real usage. You can play around with different tokenomic ideas in order to get real adoption as well. And I think there's still something that remains to be done to make it true that you can launch your own valuable L1 with the same level of ease, right? And interchain messaging is how you go about solving that. Because when it comes, I've seen some posts from a couple of the really smart guys at Blockworks about, it's still hard to launch an L1, right? And a big part of that is there's a bunch of integration and human connectivity things you need to do in order to do it well. That comes from attracting a validator set, that comes from getting stablecoin integrations, basically all of the things that we expect out of any lively ecosystem, any chain that we use and interact with. And cross-chain messaging basically makes it so you can plug your L1 into an existing ecosystem that already has all of those pieces, right? So the whole point of interchain messaging is to make it easy to connect across all of the value and services that exist across the entire ecosystem. And when you do that, you're really just making it so all of that work is done for you. Another person I'd say who was really smart described, I was talking with him about using the Hyper SDK. He asked me a really, really great question, which is when he was deciding where to build on chain. And he asked me a really great question, which was, what work have you done that will save me 2 years of work in my project? And I think that's the reality of what we're talking about with both interchain messaging, SDKs, as well as, there's so many other things where that's the real question we should be asking. And interchain messaging, it removes a lot of those integration points.
So Avalanche essentially is the glue between all these independent operations of L1s.
I don't like the term glue because it sounds.
What term would you use? The connecting point. I don't know. That's like good glue.
I don't know. Glue sounds wrong to me just because it sounds like everything is densely connected. I think connecting point is maybe a bit better. I should probably come up with a better word for it.
For the next webinar, we'll do that. Yeah.
Yeah. The next webinar.
Okay. Well, what about maintaining liquidity and then like communication with the ecosystem? Like, how does ICM kind of play a role in that as well? Maybe to the point that you were just making, Aaron, that it is providing that to all of them. But let's just say I launch an L1, right? Does it actually come with all that, or how does it actually play out?
Yeah, I mean, I think we could talk about what it was like building Avalanche and when we deployed the first bridge between Avalanche and Ethereum. That was a pretty big. Michael, do you want to?
I mean, I'm not sure I want to revisit those days.
Was it dark or was it a positive moment? Come on.
A lot more activity.
There we go.
Definitely highlighted how difficult it is to launch bridge and how far the space had to go to the point where you can confidently launch your own L1 and seamlessly interconnect it with other chains. I think. Actually, just going back to like what term you would use for 1 second. I think we have referred to the P chain kind of as a validator registry of sorts, which enables interchain messaging. You can think of it really as like a phone book, where as long as your L1's name and number are in the phone book, you're able to connect with any other L1 who's listed there, and they are able to connect with you also if you choose to answer the phone.
I love that.
To go along with that analogy. And that's kind of why you need to pay that continuous fee to register your validators on the P chain, is because it allows for that discoverability. Theoretically, if someone knows your phone number and it will never change, they can call you without looking it up in the phone book. But in order to make sure it stays up to date and everyone has that seamless communication lines, that you need to keep the phone book up to date. But as far as liquidity is concerned, ICM itself is really kind of the primitive that allows the liquidity to be moved. But there's further contracts that need to be developed to make sure the tokens are locked and represented in the right places at the right times. And that is what we call interchain token transfer. They are a set of EVM smart contracts that use ICM to allow any existing token, whether that be a native EVM token or ERC20, to be moved to any L1, and then from other L1s to be moved amongst themselves. And the unique thing about it is that you get to, one, use it out of the box. So if you launch your L1 and you want USDC support on it from day one, you can launch that contract and move USDC from the C chain into your own L1 without any other trusted intermediaries other than the validators of your own chain. And two, L1s get to choose their own representation of those assets within their own chain. So if you want USDC to be your native EVM token, you can do that. If you want it to be a similar ERC20 contract as it is represented on the C chain, you can do that, or any other crazy thing that you can think of. So there's customizability in how those assets are represented within L1s, but they can be moved seamlessly between them.
Yeah, no, that makes sense. I like the phone book analogy. That's better than glue. I think that's way more understandable and like makes a lot more sense in this situation. In regards to...
That was the first time I used it, actually. So
well, now they're going to use it all the time, and they're going to have to credit you.
That's pretty cool.
Oh, yeah, right. The phone book. What other technical innovations do you see kind of deriving from Avalanche 9000 to maybe facilitate interoperability without requiring bridging solutions and so on? And like, how do they kind of differ from other innovations that might be out there already today?
That's a great question.
It's a really good question.
Thanks, guys. That's why I let you pause. Go ahead.
Could you repeat that
I don't know,
question?
Aaron, if you want to.
Yes. To repeat the question, what other technical innovations does Avalanche 9000 enable to maybe facilitate interoperability without requiring bridging solutions? Or how does it differ from other innovations or use cases that are out there today?
I think we could talk about.
So-
all right, go ahead.
Yeah, so I think the thing that interchain messaging really brings is this kind of really fast and efficient messaging across layer ones, right? And so the Avalanche 9000 stuff was all about kind of making these layer ones cheaper and easier to launch, but ICM isn't just something that is used for, say, token bridging or things like that. Now, I use the word bridging, but it's actually using the full validator sets from both sides. So even though it really looks like a bridge, there isn't that trusted intermediary that most bridges that are transferring assets have. So this is a really flexible and powerful primitive, because again, you can just send messages between each point. So it isn't necessarily just going to be asset transfers. And in fact, we actually use ICM for the registration of validators within the P chain as I think a great example of a use case of ICM that is not actually transferring assets from one place to another. So I think other usages of ICM we're really interested in is actually kind of like an Oracle layer one, say, where some layer one publishes, hey, this is my current price feed for this off-chain thing, and now with ICM you can do interesting things like broadcast messages, where in fact any layer one can read that in, authenticate that it came from this Oracle layer one, and then use that kind of most up-to-date price feed. And so we've been working with various people for things like that, where it's not just necessarily like something that replaces a bridge, but it's really a like arbitrary messaging component between layer ones. So this isn't that component is not necessarily something that was introduced in like Avalanche 9000, but by making launching layer ones cheaper and actually kind of like usable, it allows for that network to come up where you have these specialized networks that can provide this specific service. And so I think that the innovation is going to come out where more and more people are using ICM for different and more interesting things. So I think that that's the thing that I'm most interested in from Avalanche 9000 actually, is just how people start using ICM in this kind of heterogeneous network. Yeah. I don't know if I answered the question, but I think I gave it at least a college try. So
you're allowed to answer the question however you want. That's the beauty of a panel. But maybe stepping back from L1s, how has Avalanche 9000 improved the ability for applications in sectors like DEXs, AI agents, and Web3 gaming to interact, especially within Avalanche?
The cost is lower. I think this is really the main one. I think so. There weren't actually changes to the cross-chain messaging protocol itself. That's actually been there for 2 years, 1 year now, I think, right?
Still under a year. Yeah,
still under a year. Okay, still under a year. But yeah, it's hard to answer these questions. What's that?
At least for the C chain.
At least for the C chain. It's kind of hard to answer some of these questions that are like, what it's primarily it was lowering the economic barrier, and then reducing the fees on the P chain. So I think to talk about, what more there could be, I think as another example, whenever you decrease fees on any of these general purpose chains, you see a lot more activity, simply because you've lowered the price to the point that it makes sense for new users to trade. I think one of the biggest ones that steps up the lower the fees go is bots, which is not necessarily really thought of as a good thing, right? Like, oh, well, what portion of your usage is actually from bots? But at the end of the day, it is usage and it's paying usage. And that's what we've usually seen across Avalanche and many other chains, is that if the fees are sufficiently low for bots that can very easily do something automated, it's just very, very easy to increase their transaction usage. Oftentimes when they're doing some sort of like very naive strategy where they're just trying to put a bunch of transactions in a block to look for potential amount of opportunities or, you know, whatever else might be there, that wouldn't make sense if the transaction fees were higher. So I think that in a similar way where that increases bot activity and prices in new users, I think that we might see, you know, more activity as a result of that as people start to use ICM, just because it's gotten several orders of magnitude cheaper. So I think, I don't know, it's hard to predict what that might be, but I think there's a very real possibility, you know, we'll see an influx of users that say, oh, well, at this price point, actually, there's a whole different set of things that are possible and that are reasonable.
Yeah. I know at the last Avalanche Summit, I was talking with some of the team from Dex a lot, and they were talking about how they had, you know, were in the process of switching over from running their own bridge to using ICM because it was substantially cheaper. And so you start to kind of like see that, you know, that adoption, and, you know, hopefully see a little flywheel of activity of the different networks. Yeah.
Yeah, no, that makes sense. Yeah, Michael, go ahead.
The one non-technical aspect of Avalanche 9000 that we haven't touched upon yet was the Retro 9000 grant program also, which I think was very much oriented towards all of those potential use cases or verticals or sectors, whatever you'd like to call them, to experiment launching your own L1 and seeing what's possible now that it is more flexible. And, you know, I think to a large extent, I think we view our role as kind of creating all of the conditions and frameworks necessary to make it easy and make it attractive to launch your own L1. And what that leads to as far as the experimentation and use cases on top of it is what we're looking for others to come in and build. And both on the technical side, making things cheaper, making them more seamlessly connected, more flexible, and on the non-technical side, as far as the Retro 9000 grants, I think we're really putting a coordinated and concerted effort into making the conditions as optimal as possible to come in and test the waters with what's possible in Avalanche.
Yeah, you actually beat me to my next question. It was going to be about Retro 9000, which for those who don't know is a $40 million grant program to incentivize developers. Instead of predicting, I'd love to hear what you all would like to see built on Avalanche. Like, what's something that, like, while you're working internally at Avalabs, you're interested in and you're like, damn, this would be really cool if someone built a project on this?
I've got one.
Go ahead. Share it.
Okay, so the one I was talking about this, I think I've told Steve and Michael, sort of lame, not that cool, not that inspiring. The one that I'm particularly into right now is, well, I have this Whoop fitness band on now.
Yeah.
I'm really into this. I really like it. I've had it for, I think, 2 years now. And one application that I really want to see built is a way to make it so I can interact with my own private data in a way that's composable. So store my data in something that's secure, nobody has access to. This isn't necessarily even on-chain. It could be some team mixture, but, you know, it's in a sort of pseudo Web3 space mixed with AI potentially, of just some way to have this data be secure, but enable people to perform computation on it and make it so people can build their own plugin, sort of like a Jupyter notebooks for my own fitness data that's still private. That's the way that I sort of think about it. I would really like to see that, because I would really like to use that and sort of just nerd out on it, as well as, you know, obviously it would be very cool to have some form of aggregate data that people can perform computations on as well. I'd love to play around with that kind of data as well. So that's not Avalanche 9000 specific at all, but if anybody's watching this thinking this would be cool, would love to see it built in any way, whether that's T's, AI, on-chain, whatever, any mix of that, I think would be sick.
Yeah, maybe you could get some of the money from the grant program. You know.
Yeah.
Fingers crossed. No promises, no guarantees. Okay, what about you two, Stephen, Michael?
If we're not careful, I'm gonna start shilling my like casino chain stuff.
Yeah, do it.
Yeah, I mean,
I'll go on a very.
You can answer the question however you want. Yeah.
I'll go on a very short rant, which is, at the end of the day, blockchain is a trust minimization technology. And I think that the best use cases are use cases where in the current world, you have a large amount of required trust, and especially in a case where the people that you are trusting are not necessarily trustworthy. And I cannot think of a bigger thing that screams that than random sketchy online gambling sites. And so it is certainly difficult to be able to kind of implement, some say like on-chain gambling mechanism. And it's also kind of like not necessarily like the proudest, application to use, but it is at the end of the day, like this is actually a great use case for blockchain. Like I'm not necessarily saying that like I want to like run some casino chain, but at the end of the day, like I do think that that's actually like a large market that does exist that blockchain actually can substantially improve. So I think that that's a very interesting kind of area that, it tickles my brain both like intellectually because it has a lot of fun and interesting problems, but also because I do think that it actually can, at the end of the day, provide a substantial like improvement. So
Yeah, 100%.
also shout out to the person in the chat. This is a live thing, just so you know. Anyways, yeah. How about you, Michael?
So I'd go a very similar route as you, Stephen. I think I'm a huge sports fan. I would love to see a combination of like prediction markets, sports betting, on chain, and driven by an Oracle validator set that also serves as the oracles for the outcomes. So you could feasibly use like interchain messaging to require that like validators post the results of the given games, and like a threshold of your validator set has to agree upon what the result actually was, whether it's sports or not, for a prediction market type of application on an L1. And you could use ICTT to move the tokens into it. So it seems very feasible, and potentially like reward the validators that participate if they actually provided their signature with the end result. So if you say have a prediction market on who will win the Super Bowl, and then eventually if the validators provide their signatures for who they attested to winning, and then they get some amount of rewards from the pool or something. I haven't thought fully through it, but it seems very feasible and would be really cool to see, because I think it, similar to what Stephen said, is a great use case where we don't need these intermediaries to have a very similar level of user application, but in a trust minimized manner.
Yeah, no, 100%. I think all those categories make sense. Fitness, sports, and then gambling that's loved by everyone across the globe. Doesn't matter where you are, right?
Yeah, we got Inertia Social is also, Inertia is building on Avalanche as well. I think we
had Inertia on my podcast, actually. Yes, they were great.
Yeah, they're awesome.
I want to remind people who are listening in that this is live, yes, and we are doing Q&A. We got some good questions that I will give you guys at the end. But before we get to that, one last major question from me is, obviously, you guys were insanely busy, I'd imagine, in 2024 working on Avalanche9000. What else is on your roadmap for 2025? What are you excited about?
So I would say there's a few different things. To date, a large part of the focus on Avalanche has been on this interchain thesis, and making sure that we provide all the frameworks necessary for that to flourish. But at the same time, we also have had a number of efforts that have been more in the background as far as pushing the performance of any individual chain. And now that Avalanche9000 is out, excited to bring those from the background to the foreground. All the way from the storage layer to the Hyper SDK that Aaron has been working on, to potential optimizations to the EVM. So a lot of different pieces of the stack, but all aimed towards improving the performance of any individual chain. And then also, I think there's optimizations to be made, and one of our engineers, Cam, actually just recently started an ACP discussion on making the P chain and L1s more robust as far as the construction and verification of ICM messages and their isolation to one another. So those are definitely more technical oriented, but important pieces of the longer term puzzle as the network continues to grow.
Amazing. Stephen?
Yeah, I think so. Like Michael
Yeah,
said,
I think
you go ahead.
sorry, my internet is a little weird. It might be laggy. But no, yeah, I think I have to jump on with Michael and say, yeah, I'm really interested in kind of pushing the limits of single chain scaling. I think this might be what Aaron is going to talk about as well with HyperSDK. But yeah, we spent a lot of time kind of working on this kind of horizontally scalable structure with subnets and L1s, and now I think that we want to kind of put a little bit of effort into improving or a little bit more effort and kind of pull across the finish line some of these long projects about single chain scaling. So that's definitely a huge area that I'm looking forward to in 2025.
Yeah, I think this is one of the most interesting engineering problems to work on. And I'll also add, me and Steven were at the IC3 winter retreat at the moment. So we're with a really great group of researchers, and it's been really fun and enlightening to have a lot of conversation with people that are working on, one element of the stack. And they're going through, it can be very difficult to say, well, I just want to override the consensus protocol and I want to plug in one place very, very easily. And despite, there are solutions that are out there, but most of them have very difficult to use interfaces. And there's just so many incredibly brilliant people that are here and, all over the world in different communities as well, that want to play with one thing, and they want to see, detailed metrics on what the actual problems are. So I think two of the things I'm most excited to see in the HyperSDK development is exposing those easy to use interfaces so that people that are doing research or want to play around in one particular area can focus on that one particular thing and just put it into a running overall system very easily. And the other one that I'm very excited for is creating easily reproducible benchmarks with metrics that are very, very easy to see, use, and see, see and use. Because also talking to a lot of these folks, one of the very difficult things about research is actually, it's not doing the research, although that's difficult as well. But one of the most difficult parts is actually choosing the most valuable research to do. And this is one of those things that I've heard many professors talk about having a sixth sense for. It's very, very important, and it can be very difficult to do. And oftentimes it comes from working with industry partners that have an idea of here are the problems that we're running into in production. And I am very hopeful that we'll be able to produce very clear benchmarks we can share extremely openly. That say, here it is running a production workload. We have all of these metrics you can look at. You can see it runs into a bottleneck when we hit this point. And one of the other nice aspects of the HyperSDK, as well as the changes Steven's made on the P chain, is when you get to the point of providing multi-dimensional fees, you actually have it broken down into here's all of the different resources and where we're consuming them. So I think one of the nice properties that has is we can say, well, the bottleneck will be X at this point. And if you want to increase that, this is the sort of toggle that you have to play with or do research on. So it's a very difficult thing to make that as easy to interact with. I'm already seeing this of like, oh, well, I thought this would be a very simple API to expose, but it gets harder and hairier at different points, but still trying to make it so that's very easy data for people to interact with, and working with that broader research community to say, here's a problem that we're running into. I think providing very easily reproducible metrics and being very honest about it will hopefully lead to a lot of interesting results and a lot of great collaboration.
Yeah, no, that's super interesting. And I'm excited to see how that all transpires for you guys. To wrap things up, I have a few questions here that we pulled from the community. Question number 1, what's your view on future growth of the markets for L1s by segment, gaming, other industries, banks, etc.?
It's more of a question for Luigi oftentimes.
We're going to have to pull him in. Phone a friend.
I think one of the ones I'm most excited for is inertia. I wouldn't be very good at commenting on here's exactly where we're going to see the most growth. I definitely think I'm not a gamer, so it's hard for me to comment on the growth of gaming, but this is definitely something that I've seen externally, largely with Off the Grid as one example, where I never really played video games too much growing up, but it's really easy and amazing to see Off the Grid as one of the top games that's been released in the past year, Web3 completely aside, and then to just look at that and say, well, if people have the choice between playing Off the Grid, and I can't even think of the name of another game, but another game that's of similar quality, and one of them is going to pay them a bunch of money, whether that's tokenomics or speculation driven, if you're a game and you're trying to drive a user-based adoption, right? Like, I think that's a really attractive part of building in Web3. And throughout the history of computing, gaming has oftentimes been one of the early adopters. So I think that's one of the biggest possibilities. And obviously I'm biased towards fitness too, and handling it in interesting ways. But I think teas might be a better way to handle that in a lot of cases.
Yeah, for sure. And then the second question was, Avalanche9000 seems largely focused on horizontal scaling. What other major improvements remain before turning focus to vertical scaling improvements?
That's our next focus. So
vertical scaling is the next focus?
Yeah.
Well, that was quick. Anything else you want to add on that, or is just straight to the point?
There will certainly be like additional improvements on like the horizontal scaling side, but I don't think that we are currently planning any like large changes. I think that there will probably be a number of quality of life changes and improvements, stability improvements. But I think that as far as user facing focus right now, we're definitely focusing on vertical scaling of chains. Yeah.
Yeah. Okay. Amazing. Well, I think that's all the time we have today. So thank you to Aaron, Michael, and Stephen for your insightful comments and entertaining all my questions. And thank you to everyone for listening in. I'm excited to talk with the Avalabs team again next quarter.
Can't wait.
Thanks.
Yeah, thank you for hosting. It's been great.